Hi guys, hope you all are doing well. So here we are back with one more video, and in the previous class we had done a small series of finding out the specific heat capacities for monoatomic, diatomic and polyatomic gases. Today we are starting with something called as absorption, reflection and transmission of heat. Now before we start, in case you haven't subscribed my channel, just go ahead and please subscribe the channel so you can follow the updates and we can complete the chapter as early as possible. Now let's get back to our topic. The topic's name is absorption, reflection and transmission of heat. So how a body can absorb, reflect and transmit heat radiation, we are going to discuss in this particular video. So I'm assuming that this is my body, one body, okay, and Q amount of heat energy is incident on the body. If you can see the arrow is pointing inwards, that means Q amount of heat energy is incident on this body. Then this body has a capacity of accepting the heat as QA. So QA amount of heat energy is absorbed. Some part is reflected, so I have written that as QR. QR is the amount of heat energy reflected. So if you can see the arrow, it's pointing outside. And QT is the amount of heat energy transmitted. I am writing that as QT. Okay, so the arrow is pointing outside. Now we can generalize this one equation which says Q, that is the total amount of heat energy which is incident, is equal to amount of heat energy absorbed plus reflected plus transmitted. So this is one very logical equation we have made, that amount of heat energy incident, that is Q. So Q is the amount of heat energy incident, QA is the amount of heat energy absorbed, QR is the amount of heat energy reflected, and QT, finally QT is the amount of heat energy transmitted. So transmission, basically like heat energy is incident, but it is not absorbing, it is not reflecting, it is just making the energy pass through the body. So that's what is called as transmission. Now if I divide this whole equation by Q, so I would get something like this, that is the amount of heat energy incident. So I have just divided those equation. If you can see, divided by Q, Q, Q and Q. Now Q and Q gets cancelled, I get 1, and this QA upon Q, we cannot cancel this, but yes, this QA upon Q is written as only A, small a. This is written as small r and this is written as small t. Now many times what happens is, okay, we refer after let's say few days and then we find out that Q and Q has got cancelled over here. It's not like that. I mean, you cannot cancel like that. And QA is basically the amount of heat energy absorbed and Q is the amount of heat energy incident on it. Definitely this would be a lower value and this would be a higher value, and this ratio is what is written as A, this ratio is written as R, and this ratio is written as T. So I've just written it over here, where A is the coefficient of so A is called as the coefficient of absorption, R is the coefficient of reflection, and T is the coefficient of transmission, which is QA upon Q. Now all these values would be always less than 1. So the value of A will always be less than 1, QR will always be less than 1, T will always be less than 1, because the total is 1. So definitely the value would always go less than 1. Yes, that means the value will always be between 0 and 1. Okay, now let's discuss about each and every one, like coefficient of absorption, reflection and transmission. So this is going to be a very short video, and I have written it for you. Okay, so here it is. So coefficient of absorption, it is defined as the ratio. It is defined as the ratio of amount of heat energy absorbed to the amount of heat energy incident on it. So defined as the ratio of the amount of heat energy absorbed to the amount of heat energy incident on it. That's what is called as coefficient of absorption. It is also called as absorptance, if you can see this, absorptance, or it is also called as absorptivity. So both names are used alternatively anytime in different boards. So the formula for A is equal to QA, that is the amount of heat energy absorbed to the amount of heat energy incident. So coefficient of absorption is defined as the amount of heat energy absorbed. It's the ratio of the amount of heat energy absorbed to the amount of heat energy incident on it. Because the numerator is energy, the unit is joule, and the denominator is also an energy, so the unit is joule. So joule and joule gets cut, so you get no units, and it will also have no dimensions. Now just a logical statement. If a value of a is high means it is near to 1. So let's say if a ka value is 0.9, and if r ka value comes out to be 0.4, and t ka value comes out to be just a minute, a ka value comes out to be 0.9, r ka value comes out to be 0.04, and t ka value comes out to be 0.06, because the total has to come up to be as 1. So a is 0.9 and nothing is there, means 0. R is 0.04, t is 0.06. The total has to come out to be as 1. Okay, 1. So if you see, this has a very high value of A, very low value of R, and very low value of T. So this body should be a good absorber, and if it is a good absorber, then definitely its reflectance and transmittance is low, so that this body is not a good reflector and not a good transmitter. And you can just work around on the other side as well. So we have done it for coefficient of absorption. I would request you to pause the video here and just try to prepare for coefficient of reflection and coefficient of transmission. The definition would just be a change in minor quantities, like you just have to if I just mark it over here, like this, absorption will become reflection, this absorbed will become reflected, then absorptance will become reflectance, absorptivity will become reflectivity, A will become R, A will become R, that is the amount of heat energy reflected, A will become R, no unit and no dimension would remain same. And the body, if R ka value, if I say that if the value of R, let's say if the value of R is high, that is near to 1, then the body should be a good reflector, and it should be a poor absorber and a poor transmitter. So like I've just done it for you, but yes, you can surely do it for yourself. I have done it for, in case if you want to just tally what you have written, then this is what it is. So coefficient of reflection is the amount of heat energy reflected, and it's the ratio of amount of heat energy reflected to the amount of heat energy incident on it. It's called as reflectance, reflectivity, and R is equal to QR upon Q. It has no dimension, no units. If R is high, it's a good reflector, but it's a poor absorber and poor transmitter. Then I have done it for transmission as well. It is defined as the ratio of the energy transmitted to the amount of heat energy incident. It's called as transmittance, transmittivity, and T is equal to QT by Q. No unit and no dimension. If T ka value is high, then it's a good transmitter, but it's a bad absorber and a bad reflector. So this is what it is. I just zoom out so that in case if you want a single photo of this, you can just click a photo. Maybe it's very small, but you can just magnify it, and you can just try to remember it and learn it comparatively. Okay, so you can screenshot this. Okay, and so today we'll be stopping at this video, and I hope you have following with the videos, and in case you haven't subscribed it, just please subscribe this channel and keep following. More videos are lined up, and I'll be posting it as and when. Thank you so much for watching the video. Goodbye.